Greetings, Mr. Sutton here with the Pre-Cal Honors 4-4 Part 1 Homework Solutions on Laws of Logarithms. For number 1, they want us to write this expression in terms of individual logarithms. So we're going to do this in two steps. For the first step, we're going to take care of the outer function, which is division. So what does log do to division? Well, it turns it into subtraction. So we can express this as, and actually there's multiplication which we can turn into addition here. We can express this as log of a plus log of b squared minus log of c cubed. And then as a next step, we can use the pop-out rule. These exponents can come out in front as coefficients. So log of a plus 2 log b minus 3 log c would be our final answer. For number 2, we're trying to turn log of cube root of x over y into individual logarithms. The cube root is the outer function here, so we have to take care of that first when we log this. So we can pop that out as an exponent. This is really the 1/3 power that we can pop out in front. And then we can turn this division into subtraction of logs. Now, when you do this, you really have to distribute this 1/3, since this is turning into log of something minus something else. So we'll have 1/3 log of x minus 1/3 log of y. Alternatively, you could just write 1/3 parentheses log x minus log y, and it would do the same thing. For this problem, I'm trying to break this expression down into individual logarithms. So the first thing I'm going to do is take care of the division or multiplication that's going on inside the logarithm. So I know that multiplication is going to turn into addition. I can then write log of x to the 8th plus log of y to the 5th. And I also know that division inside logs turns into subtraction of individual logarithms. So we're going to write minus log of z. Next, I'm going to use my pop-out rule and turn these exponents into coefficients. So this is going to be 8 log of x plus, this pops out to give us 5 log of y, and then just minus log of z. For this problem, I'm going to start, when I'm breaking this expression down into individual logs, I'm going to start by turning multiplication inside the log into addition of logarithms. So I'm going to end up with log of x to the 5th plus log of y squared. Next, I'll use my pop-out rule to turn exponents inside logs into coefficients outside the logs. This will be 5 log of x plus 2 log of y. For this problem, we want to write this whole expression as a single rational number or logarithm. We're going to start with our pop-in rule. So this becomes log base 6 of 9 to the 1/2 power. And let's see here. I can actually simplify this a little bit already. I know the 1/2 power is really just square root. So this is log base 6 of 3 plus log base 6 of 5. Next, if I'm adding the logs, that means I'm multiplying the stuff inside. So this is log base 6 of 3 times 5, which is really just log base 6 of 15. Now, is there a number I can raise 6 to get 15? Well, of course there is, but it's not a nice whole number or even a fraction, so I am done with this problem. For this problem, I want to merge these into a single log or a single number if possible. Let's start by popping in this 1/3 as an exponent on the 27. And then if I'm taking 27 to the 1/3 power, that's the cube root of 27, which is 3. Next, the subtraction of logs, I know really just means I'm dividing the numbers that are inside in one big logarithm. So I can write this as log base 2 of 48 over 3, or log base 2 of 16. And I know that 16 is a power of 2. It's 2 to the 4th. So log base 2 of 16 just comes out to 4, which will be our final answer. For number 7, to turn this into a single log, we need to start with the pop-in rule. So this 1/2 will come inside on the 5, and then we'll have ln of 2 to the 3rd power. So we can rewrite this as the square root of 5 if we wanted, and this over here as 8. To add these logs, we have to multiply the stuff inside. So this will really be ln of radical 5 times 8, or ln of 8 radical 5. For this problem, I want to write this whole expression as one big logarithm or a single rational number if possible. Probably not going to be possible to write it as a number with all these variables inside here though. So we're going to start by turning addition of logs into multiplication of their arguments. So this is just log of 2x to the negative 4th y to the 3rd times 4xy to the 5th. And let me go ahead and actually simplify that stuff inside now. So 2 times 4 is 8. We've got x to the negative 3rd if we add those exponents, and y to the 8th. And then just one more little quick step here. I'll just move this x to the negative 3 downstairs as an x to the 3rd, and can't really do any more there. For this problem, I want to rewrite this expression as a single log or rational number. Let me start by popping this 2 in as an exponent on the 3. Next, I'm going to turn this addition of logs into multiplication of the things inside. So I've got log base 6 of 24 times 9. And what is 24 times 9? Well, let's see. That's going to be 180 plus 36, which is 216. Log base 6 of 216, I'm asking, what do I have to raise 6 to get 216? That's going to be the 3rd power, so I can simplify this to just simply 3. On this problem, I'm trying to turn ln of 54 minus 3 ln of 3 into a single rational number or a single log. Let's start by popping this 3 in as an exponent on the 3 inside. So this will be 3 to the 3rd inside there. Next, subtraction of logs turns into division of the items inside of them. So this is going to be ln of 54 over 27, which I can simplify to ln of 2. But 2 is not a power of e, so I can't really go any further than this.